All right, we got shifted conics today. That's shifted conics. Please be careful how you say that. These are the same conics we've just done for the last few days, except now the center or the vertex, whatever, is not going to be a 0, 0. So let's see what they look like. Didn't do that. Okay. Basically, the x or the y is going to replace by the x minus h or x plus h, which is going to move it right or left. You know the gesture for that, opposite of what you think. And the y is going to replace by k minus k or plus k, which you know the gesture for that, exactly like you think. So that's what's going to happen. Same figures, same pictures, just been shifted. All right, shifted ellipses, first of all. This is what we saw earlier when we did ellipses. We saw them, they all look like this. The center was at 0, 0 at the origin. We had a major axis, a minor axis. Today, the only difference is we're going to shift it h to the left or right. We're going to shift it k up or down. And the same stuff is going to be true. The equation is still going to equal 1. But if you look at the h and k on the top, it's going to look just a tad bit different in the numerator. So let's look at 1. All right, this one says sketch the graph of this ellipse. Now, the only difference from what we did the other day is the center of the ellipse is the opposite of what's inside your parentheses. Okay, so we're going to go 1 left up 2 before we draw our ellipse. So I'm going to make this graph a little bit bigger down here. I'm going to find 1, 2, first of all. Negative 1, 2, sorry, right there. Now look what's underneath my x, which is the minor axis. It's 4, so I'm going to go right 2 and left 2, just like that. Look underneath the y is a 9, so we're going to go up 3 and down 3 from the center. And the ellipse will look just like this. Okay, that's the only difference. It's been shifted. Shifted parabolas, same deal. The parabolas we did last time, the vertex was always at 0, 0. Now, a little bit more complicated with the parabolas. The 4p still goes on the opposite side with the square. All right, 4p, opposite side of the square. If the x is squared, it goes up or down. Oh, we talked about this. 4p, wherever the 4p is, tells you how it goes. The 4p's with the y, it goes up or down. 4p's with the x, it goes left or right. And the shift is just the opposite of what's inside your parentheses. Okay, so let's look at one of those. It says determine the vertex, focus, and directrix, and sketch a graph. So we got to find all the stuff and sketch a graph. Oh my goodness, what are they thinking? So a little bit different here because I have an x squared and a 4x. So watch what I'm going to have to do here. I'm going to say x squared minus 4x. I'm going to leave some space. And over here I have an 8y minus 28. Okay, now I can't write this right now with the x and like a square like that, which is what I need. And here's the deal. Anytime you need a parentheses with a square on it, but you don't have it, you have to complete the square. So I'm going to take half of this negative 4, which is negative 2, by the way, square it, that's plus 4. I'm going to add plus 4 to both sides. Over here now I have x minus 2 squared. Over here now I have 8y minus 24, which is better than what I had, because now I can take the right-hand side, factor out the 8, which, by the way, is my 4p, and I have y minus 3. Okay, so my vertex is going to be the opposite of what's inside both parentheses, 2, 3. So I'm going to go ahead and go to 2, 3. There's my vertex. Now, because my 4p is with the y, I know it's opening up. All right, so because it's positive, so it's going to open up like this. And it said what to find. We need to find the focus. Remember, the focus is p away from the vertex. Well, 4p is 8, which means p is 2. So it's going to be up 2. So my focus is going to be right there, 2 up from 3, which means the focus is at 2, 5. It also said find the directrix. Well, the directrix is going to be p away, except the other direction. There's the directrix right here. It's that line that's 2 below. So it's going to be y equals 1. And that's all we had to find. Okay, those 3 things and the graph. Not that bad. Shifted hyperbolas. You knew this was coming. The last shape we did was hyperbolas. The other day they're centered at 0, 0. Today they're not. Okay, so remember the major or transverse axis on hyperbola was the positive one. In this case, it's the x. In this case, it's the y. Is the majors. The y is it goes up and down. The x is it goes left or right. So let's look at one of these. Shifted conic has that equation, and I'm not sure what we're supposed to do with that. Hang on one second. Okay, we're just going to figure out what it is. Okay, now, here's one thing I know. I see a positive 9x squared and a negative 16y squared. So I know it's a hyperbola. So watch what goes into this right here. I'm going to put my x's together, but I'm going to go ahead and factor out the 9. So it gives me x squared minus 8x. I'm going to leave some space because I need a parentheses with a square, and I don't have one, so I have to find one. I'm going to take out a negative 16 here out of my y's. And if I do that, that gives me a plus 2y. Because I took out a negative 16. And over here, I still have the 16. Now watch what happens here. This is crazy. All right, so I need to complete the square because I need a parentheses with the square. So I'm going to take half of -8, which is -4. Square it, that's 16. Now, because I added a 16 here, you would think I would add a 16 to the right-hand side, but I really added 16 times that 9, which is 144. So I have to add 144 to this side, which is crazy. Okay, so the second parentheses, if you take half of 2, that's 1. If you square it, it's 1. It looks like I added 1. I didn't. I added -16 because it's really 1 times -16. So here's what I have. I have 9 times x minus 4 squared minus 16 times y plus 1 squared equals over there 144. Now, I know it's a hyperbola, and remember, you want the right-hand side to equal 1. So I'm going to divide everything up there by 144, each term by 144, because that's going to give me a 1 on the right-hand side. Now, luckily, 9 goes into 144 16 times, and 16 goes into 144 9 times. So there's my equation. The center of my hyperbola would be 4, -1, because that's what's in my parentheses. The opposite of what's in my parentheses. The transverse axis would be your x-axis. So the transverse is the x, and the square root of 16 is 4. You'd go 4 right and 4 left. That means it's 8 units long. The conjugate or minor axis would be 3. The foci, we could find that too. Then c squared is a squared plus b squared. It actually, if we did that, if we did a squared plus b squared, it'd be 16 plus 9. So c would be plus or minus 5. So my foci would be at plus or minus 5 and 0. If I did have a graph here, I would go to 4, -1. 1, 2, 3, 4, -1. There's my center. And I would go, let's see, I would go right 4, 1, 2, 3, 4. Left 4, it's right there. Up 3, 1, 2, 3. Down 3, 1, 2, 3. And I would draw my little box like we always did. Like this. And I connect those with asymptotes, like we always did. And because the x is the major, the hyperbola would go this direction. Okay, I should have put a picture of a graph on there, but I forgot. So there's all your stuff. Okay, so the general equation of a shifted conic is going to look like this. Okay, it's going to have everything written together with the x squared and y squared, where a and c are both not 0, which means you have to have either an a or c. Usually you'll have both. It's either a conic or what's called a degenerate conic, which we'll talk about in a second. In the non-degenerate cases, the graph is a parabola. If you only have one square, if a or c is 0, I mean one of the squares is gone, that's a parabola. It's pretty obvious. It's an ellipse if a and c have the same sign. It's a circle if a and c are equal. It's a hyperbola if a and c have opposite signs. And that's how I knew the last slide was a hyperbola, by the way. Okay, a degenerate conic. Some cases, the graph of the equation turns out to be just a pair of lines or a single point, or there might not be a graph at all. Okay, and this is one right here. I'm going to show you what a degenerate one looks like, and so you'll have an idea. Okay, so I'm going to do the same thing I've been doing. I'm going to put my x's together, 9x squared plus 18x, and I'm also going to put my y's together. Now, it looks like at first, it looks an awful lot like it's going to be a hyperbola because I have both squares and I have a minus sign. Okay, so it looks like it's going to be a hyperbola. So let's just check it out. Factor out the 9 like we did a few minutes ago because I got to complete the square. Here, factor out the negative sign. It gives me a y squared minus 6y. And let's see what happens. Right here, half of 2 is 1. If you squared it as 1, it's not really a 1 though. Remember, it's 1 times that 9. So I'm going to add 9 to that side. Over here, half of -6 is -3 if you squared it as 9. But it's not really 9. It's really 9 times what's in front, -9. So I get that. So over here, I have this. I have x plus 1 squared minus y minus 3 squared. Over here, it equals 0. And because it equals 0, there's nothing to divide by. There's no way to make that equal 1. It's not a parabola. So, it's not any of those. So we call it degenerate. It's not a very positive term, but that's what it's called. All right, so we'll work on these tomorrow. See you then.